Year 11 Chemistry Mock Exam, question 3. We start with a straightforward, quite low-level question on atomic structure. We've got 5 pictures, and it's helpful for us to go through these pictures and have a look to see what they represent and which ones actually are complete rubbish, so we can eliminate those. The A is representing the model as proposed by, well, both Bohr, Rutherford and Chadwick. So, of course, Rutherford is the nucleus, Chadwick is the neutrons, our smaller shaded things here, and Bohr is talking about the shells. So we know A is good. B is representing our plum pudding model by J.J. Thomson because it has a sphere of positive charge embedded with negative electrons. C would just be Rutherford's model without any contribution from Bohr. D is the pre-existing model of just an atom with no with nothing below, and actually technically that's not on the spec, but that would be the Dalton model of the atom. And E doesn't exist. We can cross out E. E's nonsense. There's no such thing as E. So question 3, which one shows the plum pudding model? So the one showing the plum pudding model is going to be B. People might be tempted to put E because they put that there as distracted, but it's not, because electrons, of course, aren't positive, they are negative. Which diagram shows the model of the atom developed from the alpha particle? This also actually reminds me that C is nonsense. Is it? Oh no, C is good because it's got 4 plus. So the answer there is C. It's not A. And the reason it's not A, and some people might be tempted to put A, is because A is the one that has basically been added with Bohr and with Chadwick to show the full, what we call the full nuclear model. Whereas C is only showing what Rutherford proposed, which is just a nucleus that was positively charged. And at the point of when Rutherford discovered this, he didn't understand that protons were in the nucleus. He just said that the nucleus was very dense, positively charged, and very small. So that's C. So which diagram shows the model of the atom resulting from Bohr's work? Okay, and technically it's none of them, but it is A, and I'll say why, but it is A. It's a bit confusing because it's A because A has shells, but it's not A because A is showing neutrons. So I could see why some people might get confused there, but it's certainly not any of the others. So A is the most likely answer. But I could take issue with that question and say, well, it's showing neutrons, so really it should be from Chadwick's work. But we'll give it that. It's A. Define the mass number of an atom. Now, although the mark scheme officially allows the word and, a lot of mark schemes don't. So be very careful that you always say mass number equals number of protons plus, or in words, number of neutrons. Electrons are so small they don't figure into the mass at all, but this particular mark scheme allowed and, but many mark schemes don't, so it's very important, I think, to stick to plus. 3.5, you don't have to do the mass for this because you know that the percentage abundance calculation will tell you that the mass of the isotope is going to be somewhere between 69, which is the mass number of isotope 69, and 71. So it's going to be somewhere between 69 and 71. Now, is it going to be below 69.5? Well, we know it's not going to be below 69.5 because if there was 50% each of these, it would be exactly halfway at 70. And since there's just slightly more, then we can say it's 69. To be absolutely sure, you could probably just go ahead and do the calculation. 60% times 69 plus 40% times 71 divided by 100. Now you're allowed to do this and write things next to the multiple choice question, that is absolutely fine. And if we put that into our calculator, 60 times 69, close brackets, plus, open brackets, 40 times 71, close brackets, press equals, and divide by 100, we get 69.8, which is that answer there. So you could estimate it, but in reality, it's probably better to do your working. Now, I don't see many candidates actually do their working on the side of this. It's perfectly fine to do working next to a multiple choice question or write anything next to the multiple choice question to help you answer it. 3.6, straightforward question about Chadwick. Chadwick's experimental work on the atom has led to a better understanding of isotopes. This is a question about isotopes. It's not just about Chadwick. It's a question about isotopes. Explain how his work led to this understanding. 1 mark. Chadwick discovered the neutron. Straightforward. And then it's just a question about isotopes. What are isotopes? Isotopes have the same number of protons. So you could say atomic number. But a different number of neutrons. You can also say a different mass number. So you should say and mass number, because the mass number is not the same as the number of neutrons. You could also have, that's going to get you to 3 marks, you could also have isotopes of elements are still the same element with the same properties. But you've already got the marks there, from 1 mark for Chadwick, 1 mark for saying that the isotopes have the same number of protons, and 1 mark for saying that they have different number of neutrons. 3 marks.